All right. So we've got this set of blocks and a couple of spring scales, and we're dragging it. And we want to figure out how to get this thing moving. So let's actually just kind of figure out what's going on here with the free body diagram. So I've got the normal force. I've got the pulling force to the right from the spring scale. I've got the weight pointing down. I've got a friction force pointing to the left, and I've got what I'm going to call a second spring scale force, Fs, right here. So let's see if we can actually do something, and I'm just working out number one right here. So let's see what we can actually label out here. So I know that the pulling force, well, I know that this force is 3 newtons. Now let's calculate the weight. That's going to be 0.5 times g, which is going to give me 5 newtons. Now let's balance out the vertical forces. I know that the spring force plus the normal force balances the weight, and so I have 3 plus the normal force balances this 5 newton weight, and that gives me a normal force equal to 2 newtons. All right. Now, let's see. Do we have any kind of pulling force here? Well, I don't know about that, but what we can do is we can calculate the friction force. Friction is mu times normal. Remember, friction is front. So we have friction is going to be 0.7 times 2, and that's going to give me 1.4 newtons worth of force right here. So 1.4 newtons. Now, in order to just get it moving, that means that the pulling force has to balance the friction. You know what, I'm going to write that all the way over here. And so that's going to give me a pulling force exactly equal to 1.4 newtons as well. So again, quantitative means with numbers, and I've put all the numbers in this free body diagram. Now, if the scale to the right is pulling with 0.8 newtons, and the block is moving at constant speed, what will the top scale read? Let's, I don't want to take chances. Let's completely redo all of our free body diagrams. So I'll have a normal force. I'll have the spring scale force pulling up. I'll have the weight pointing down. I've got friction here. And I've got this force of 0.8 newtons here, which is the pulling force. Let's see what we can solve for. Now, I know that since we are moving at constant speed in a straight line, I know the pulling force balances the friction. So that's going to give me 0.8 for the force of friction. Now, let's just go ahead and see what else we can calculate here. So let's get the weight. I know the weight is 0.5 times 10 newtons. That's going to give me 5 newtons. And let's get the normal force. Let's see what that is. So the normal force, friction, is mu times n. And I know that the friction force is 0.8. I know that mu is 0.4, and that's going to give me my normal force equal to 0. Divided by 0.4, 2 newtons. So let's see, what does that give me? Well, let's balance our forces in the vertical direction now. I have Fs plus Fn balancing weight. I have an unknown spring force. I've got 2 newtons here and 5 newtons at the bottom. So I'm actually getting a spring scale force of 3 newtons. Once again, interesting. So it seems that they got a very similar answer for the for the forces. So I guess that works out. All right. Now, on the next page, let's now add a 2.5 Newton force to the left and try to figure out what's going on here. So let's redraw our free body diagram. So I'm going to have the normal force. I'll have the spring scale. I'm going to have the weight force. I'm going to have the pulling force to the right. I'm going to have friction to the left. And I'm going to have this force that I'm just going to call F here, little f. I'm going to call it F nu. It's a new force. And I'll just draw it going this way, and I'll call it F nu. And we're moving at constant speed. So let's balance our equation. So I have Fs plus Fn balances W. And I have the pulling force on the right balances friction and this new force here. So let's see what we can put into our equations to solve for stuff. So I know the top scale reads 1.5. So let me just take this equation here. Let me just rewrite it and put in some numbers. So I know that 1.5 plus the normal force, the 1.5 comes from here, equals my weight, which we got as 5 newtons from before. So my normal force is 3.5 newtons. Now we want to know what this right spring scale is going to read. Maybe we can do something with this. So I know that friction is mu times the normal force. And from my previous problem, I know that mu is 0.4. So I have here friction is 0.4 times 3.5. So when we actually solve, let's just do that math. 3.5 times 4 is 2. 3 times 4 times 12 is 14. And I seem to be getting 1.4 newtons worth of force. Yep. So 1.4 newtons worth of force is what I'm getting for the friction force. Let's see what else I can do with that. So I know that the pushing force is 1.4 plus F nu. And I was told that F nu is 2.5. So I'm getting a pushing force on this new the scale, this pulling force, sorry, on the new scale. This is what we wanted to solve for, of 3.9 newtons. So I hope that's helpful. And you're going to be doing an appraisal when I see you in a couple of days that looks kind of similar to this stuff here.